Hello, everybody. My name is Sylvain Rochon, and I'm getting people to expand their human experience using cutting-edge technology. And today, I'm a little excited because at first I was reading these things. As usual, I receive a lot of articles, and I kind of summarize and analyze and synthesize. And I was like, "Well, this is really cool, and that's all right. Let's do something about energy today." But then I started kind of thinking about it. I said, "Wait a minute. This is actually way bigger than what I thought when you combine different things together." This is usually what happens, right? I just collect articles and then I put things together. I said, wait a minute. If you take all these different parts, it becomes bigger than its individual bits, right? So essentially, I'll be talking about instantly rechargeable electric cars. Because we have hybrids right now. Some people are even driving fully electric cars, and you have to plug them into an outlet to recharge the batteries. And that takes a while. It takes, I don't know exactly, but it takes a couple hours, sometimes more. I mean, we're reducing the amount of time a battery needs to recharge. And we're using, the traditional type batteries that are like kind of solid, if you will. Like it's using, sulfuric acid and some electrolytes in there, and we're recharging the electrolytes, and they remain self-contained inside the battery, so you don't really know what's in there. You just know that it's heavy and it's pretty polluting in most cases to manufacture. But your car is running on electricity, so as long as it's running on those batteries and not going to a landfill, you're pretty ecological. But with the coming new technologies, self-driven cars, you're looking at more and more electric vehicles going on the street, self-driven helicopters, drones, even airplanes have been designed. I've been talking about those as well, and I have more coming up in future episodes. There's going to be more of those, but I mean, if you're driving or calling a self-driven cars to go to a certain destination that's really quick, and it's kind of plugged in somewhere, and you kind of call it when you need it, it's not bad. But if you need to do a long trip like we do in a gas-powered car or a hybrid, eventually you have to gas up because you just run out of juice after a certain distance. Gassing up takes a few minutes. You go take a bio break at the gas station, buy a few snacks, hop back into the car, and on you go. But if your car is an electric car, well, you don't want to plug in for 2, 3, 4 hours while it's recharging. You want to go, right? Well, this new technology, and these are flow batteries. We've known about flow batteries or these concepts for a while. Essentially, you're still dealing with traditional batteries, but the electrolytes are different inside. And the electrolytes are the two components essentially in batteries that flow charges from one part to another. Let's just call it that. They're the elements that are kind of floating around that allow electrons to move from one piece to another, to kind of move out or move back in when you recharge, that kind of deal. Anyway, but in car batteries, or usually you're dealing with liquids. In flow batteries, it's also liquids, but the two liquids are separated by a membrane. The electrons kind of flow through the membranes, but the liquids remain separate. So what happens with the new research to application to make it an instant recharge at a refueling station, for example, for electrical cars, is that you're essentially refueling the electrolytes. It's just a different concept of an old technology, which is terrific. That means we don't need to reinvent the wheel. So these flow batteries, essentially, you'd go to a station, like you kind of run out of electricity, so not out of gas. You get to the station, and then you essentially take your nozzle. It would be a different design nozzle, and as you put in new charged electrolytes into your tank of electrolytes that feeds your battery power, and at the same time you're taking the spent electrolytes that was drained of electrons essentially as you drove, and so there's an exchange. Okay, so replacing the spent electrolytes with new charge electrolytes at a station very similar to the gas stations. And these gas stations that we have all over the place can just be repurposed for different fluids, essentially, and slightly different tanks and refueling and all that stuff. And you just do that once you have replaced your electrolytes with the new electrolytes. Well, you just move on and you have a new charge in your battery, and it took you a few minutes, the time of a bio and buying some snacks. Same paradigm as far as usability for the driver. That's terrific. Now, what's really, and that's cool, like, okay, you can use the same systems, you don't have to wait for the charge. That's really cool. But what really got me is, okay, well, the spent electrolytes, those can be transported back to a power plant, possibly a renewable power plant like solar or wind or geothermal, whatever. And the power plant take those spent electrolytes. What it does, it recharges them. So you have a big plant that actually recharges your electrolytes, and then the recharged electrolytes go back to the power station. So essentially you have these electrolytes that are actually cycled. They're not burned like gasoline. They're actually just spent of electrons, and they get recharged of electrons and then sent back to the gas stations, which goes into the car. The car drains the spent electrolytes to the gas station, and so on and so forth. You have a very nice cycle, and you need like filters and things like that to keep the electrolytes relatively clean, and you need to produce, because there's going to be some waste and some loss of electrolytes, you need to produce a little bit more. But these electrolytes can be, if they're flowing like that, they can be fairly much less efficient as an electrolyte for charging, which means you can make choices that are way more environmental as choices of electrolytes. Make sure that they are no problem for the environment, easy to produce, cheap, because it's easy to refuel. And you're not losing the fuel, you're not draining the fuel from the ground, you're actually cycling it. So that can actually revolutionize how we actually do things completely and make things very, very environmental. On top of it, countries like India, for example, are using a lot of investments in renewable energies. And I've got some numbers here. This is from the end of last year, early 2017. And some bidders to produce or to sell energy in India, solar energy, are bidding as low as 2.62 rupees per kilowatt hours. Now, it's a comparative, so I don't know what that means in dollars. But the comparative, like last year for solar was 4.34. So they've reduced their bidding because of all the hype of solar in India and in China and other places. They've been reducing, and also technologies has been increasing and become better for solar as well. So they're down bidding like 2.62 rupees per kilowatt hour. And just to compare, coal in India it's bidding around a 3.2 rupees. So coal power is actually more expensive this year as far as how the power companies are bidding for work than solar. Solar is cheaper. Wind is about the same as coal at 3.46 rupees per kilowatt hours. I mean, that's amazing. That means we could do this with flow batteries and provide energy, electricity to all our transportation systems, a whole bunch of other stuff. There's no wait time for recharging. You just kind of replace the electrolytes. Transportation systems are self-driven, for example, in a couple of years, going back and forth to the power plant. And the power plant is a solar plant, a highly efficient, inexpensive solar plant that is totally energy efficient. Yes. Well, more energy efficient, but ecological. So you have full cycle of a whole system that can provide energy to our whole existing infrastructure with a slight tweak. No big changes to put plugs everywhere so you can park your car for a couple hours and have a meal while your car is recharging for you to move on to the next leg of your trip. So fantastic news. I'm putting all the links, of course, in my blog, so you can check out my blog, and I'm writing a little bit more about it in some ways. You can check out some of the numbers as well. But really exciting stuff. I'm happy to be able to report it to you. Awesome. Let's encourage it. Let's invest in it. And these most of the movers and shakers are, more like Europe, America, India. So it's pretty much spread, but more companies and in other countries should become aware of it and start using those ideas and make it happen, because I think this is absolutely fantastic. All right, that's going to be it for now, guys. I'm going to check you out next week. In the meantime, please share and comment on the video if you want to see something different, or if you want to take part in the conversation. No problem. Enjoy your weekend, and I will see you next week with something different. Ciao.